Question 1. The Electricity Company of Ghana installs substation in the Eastern region worth $3.1 million. This substation supplies 140 VA and 100 VAR. What is the real power supplied and the power factor? So the power we are looking for, that is the real power, the same as active power, right? And they've given us apparent power, that is 140 VA, and we also have reactive power, that is 100 VAR. So then if you know this diagram over here, if here is Q, here is P, and here is S, and you have this angle over here, you can say that P will be equal to S cos phi, Q will be equal to S sin phi, and we know that S squared is equal to P squared plus Q squared. Alright, so then they're asking us to find the real power supplied. P will be equal to the S squared minus the Q squared, right? So then your P, that is your real power or your active power, will be equal to 140 squared minus 100 squared, right? So your P, that is your active power or your real power, will then be equal to 97.98 watts. So then we are also asked to find the power factor, and power factor is equal to cos phi. So now we know our active power or real power, and from this equation is the same as S times the power factor, because from here we said that cos phi is power factor, so we can replace cos phi with power factor over here. So power factor from this should be equal to P, that's the real power or active power, out of the apparent power. So we have our active power or real power to be 97.98, and we have our apparent power to be 140. Therefore, power factor will be equal to 0.699. Question 2 says an RC circuit having a resistance of 50 ohms and a capacitance of 80 microfarads. The circuit has an AC supply of 230 volts, 75 Hz. So we are supposed to calculate the impedance Z of the circuit and the current flowing through and the power dissipated in the circuit. Right, so if you have a resistor that is 50 ohms and a capacitance C, which is 80 microfarads, then your impedance Z is, but here we're just giving the value of the capacitance, so we can find XC. We know that XC is equal to 1 out of omega times C, or because omega is equal to 2 pi f. Right, so by substitution we can say that it will be 1 out of 2 pi times frequency. Frequency was given, which is 75. So 75 times C, that is the capacitance. We have 80 microfarad, which is the same as 80 times 10 to the power minus 6. So I'll have times 80 times 10 raised to the power minus 6. So XC to be 26.526 ohms. So then my Z, by substitution, I have R already, so R was 50, so it will be 50 squared plus XC squared, so it will be 26.526 all squared. So I'll have my impedance Z to be equal to 56.601 ohms. So now B, we were supposed to find the current flowing through and the power dissipated, but we know that V is always equal to the current times your total impedance, right? And if you want current, which is I, it is V out of Z. So I, by substitution, V, I have to be 230 volts, 56.601, which will give me, so the power dissipated, if I want the power, we know that P is equal to I squared R. And we have our current here, we've just found it. We know our R already, which is 50. So by substitution, I'll say that P is equal to, so P will be equal to, our last example says a generator draws 10 ampere when supplied from a 230 volts AC supply. If the power factor is 0.8 lagging, so power factor is equal to 0.8 lagging. What is the power consumed by the generator?
But before we continue, this video was sponsored by Sultan Drinks. Let's check this out.
Sultan, vitalizing drinks made from millennial old secret of black seed. Available in 4 flavors. Sultan Drinks, you know what you drink.
So, going back to our diagram, I can say that P will be equal to S cos phi, Q to be S sin phi. But S is equal to a voltage times a current. So I can say that P, which is S cos phi, is the same as V times I times cos phi. But we know that cos phi is equal to the power factor, right? So then we can find the power they're asking us to look for. Because I have my V to be 230, that is the supply voltage from here, and the current that it draws, that is 10, times power factor, which is 0.8 over here. So power factor, I'll just substitute it, that is 0.8. So I should have a power of, thank you.